Congratulations, you are now on chapter 2 of our course. It is a radical chapter, radical functions and transformations. So first of all, how about a quick definition? What is a radical function? It is a function with not only a radical, okay, so what's a radical? A radical is, well, that's a radical sign, and the thing inside is the radicand. So a radical function is a function with a variable with a variable, as in a letter, with a variable in the radicand. In the radicand. That's a D if you're not sure. Radicand. So just to zoom in here. So, okay, I already mentioned that okay, so this whole thing is a radical. This part here is the radical symbol. Just so you know when we're talking about things, okay? The part on the inside, so in this case it's the x here, that is the radicand. If it's a square root, we don't have to put a number, right? So, but we'll put a 2 just to show. That 2 there would be the index, okay? And the whole thing, I'll go back to green here, this whole thing is the radical. Okay, so if I said y is equal to the square root of 2 times x, that would not be a radical function because the x is not in the square root sign. Okay, so it has to be inside there. The variable has to be the radicand. Alright, so let's start off with our first little piece here. Let's sketch the graph of y is equal to the square root of x. It's kind of hard to read with all that stuff on there. Here, I'll rewrite it. Y is equal to the square root of x. Well, first of all, let's just try and let's say, hey, let's start with -1. Now, the problem is, if you put a -1 in for x, you cannot find the square root of a negative number. There's no real answer there. So the problem is that we can't do that because it's not in the domain, okay? So don't even try. So we're going to start with 0. And now, thinking ahead that we're going to be doing the square roots, let's pick squares. So 1 is a square, 4 is a square, and 9 is a square. Okay, so the square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. And the square root of 9 is 3. So there are our points to begin with. So we have a 0, we have a 1. If I go not 2 over, but now I'm going to go 4 over and up 2. So you see our pattern. We go over 1, up 1, and then start from the beginning, over 4, up 2. Okay, and we have seen this shape in the past, and it kind of looks like that. Okay, there is our basic function. That's our graph. Note the values of x cannot be negative. Also, since this is a function, it passes the vertical line test, right? Each x value has only one corresponding y value. And here is the set notation, x such that x is greater than or equal to 0, where x is all real numbers. So you can see that x has to be greater than or equal to 0. And the range as well, y is greater than or equal to 0. And it can all be all real numbers. And this is the interval notation saying the same thing. Okay, so now we're going to sketch these following graphs of y is equal to the square root of x plus 2. So now when I look at this, this reminds me a lot of saying, you know, something like y is equal to the f of x plus 2, right? Where if y is equal to, if f of x is equal to the square root of x. Another way of saying that is that my h value here, my h value is going to be equal to -2, right? It's the opposite of that 2. So what does that mean? I'm going to be shifting it left 2 spots. So instead of starting here, I'm going to be starting left 2 spots, right there. Okay, now I'm going to follow that same pattern. Remember that pattern was, I'll just review it over here. I'll go over 1, up 1, right? And then go over 4 and up 2. And why is that 4 and 2? Because the square root of 4 is 2, okay? So I will go over 1, up 1, and then I'll go over 1, 2, 3, 4, and up 2. So I've got that same shape, okay? Now, if you wanted to, you could, to begin with, have drawn the original one. This is what my original function would have looked like, and looked at those 3 points and said, at each place, move left 2. And you can see at each place they move left 2. Okay, I'm going to erase the original. If you were doing this on a test or something, you could draw that first function and then erase it afterwards. So draw it lightly with pencil to begin with and then move it over. Okay, so for our second one, this is now a k value of -1. So in other words, I want to go down 1. So if my original function, maybe I'll do my original function in green here. If my original function, again, looks like this. Okay, my new function, I'll do in blue, will be down 1. So I can do each of the 3 points and go down 1. Okay, so, and again, afterwards, what I'll do is I'll erase my original one, so I've got that there. Alright, so those are my first examples. Second example, using the given equations, explain the transformations needed to transform the graph of y is equal to the square root of x, and to get this. Okay, so kind of helps us because it does the explaining for us. Okay, next, sketch each graph. So the example asks us to explain it and to graph it, and in fact it's already done the explaining for us, so it's kind of nice. So the first part is there is a reflection in the x-axis. Where is that reflection in the x-axis? Well, that is from right here, right? That is the reflection in the x-axis, so I'm going to go like this, okay? Another way of thinking about that reflection in the x-axis, it's also the same as multiplying all your y values by a -1. Okay, that's why the reflections happen. The second thing that happens is there's going to be a vertical stretch by a factor of 2. So here I go, change my highlighter color. So this 2 here, that causes the vertical stretch by a factor of 2. So what that means is that we are not just going to be multiplying the y values by -1, we are actually going to be multiplying. This is mult, not M-U-L-H, it's M-U-L-T. Multiply the y values by not just -1, but by 2 at this point. So you've multiplied by -1, and then you've multiplied by 2 after that. So in total, you're multiplying by -2. Okay, the negative part is the reflection, and then the 2 is the vertical stretch part. The last one is our horizontal shift left by 1 unit. I've kind of run out of colors here, so I'll say horizontal stretch shift left 1 unit. That's this one right here. So that means the same as subtract 1 from the x values. Okay, so let's try these. Okay, so I'll start off by putting my regular 4 and 2. So this is my parent function. This would be y is equal to the square root of x. Okay, so let's do the first one. Let's do our reflection over the y-axis, and I'll pick some blue for that. Or reflection over the x-axis, pardon me, which is the same thing as multiplying our y values by -1. So a reflection over the y-axis, this is x here, this is y. So we're going to get, this will be at the same place because 0 times 0. This one has an x of 1 and a y of 1, so my y becomes -1 when we reflect over that x-axis. Goes over there, doesn't it? And this one, when it reflects, comes over there. So that is my reflect over the x-axis. I'll try to make a nice curve here. Like that, okay? So what is this now? This is the y is equal to -√x. So that's all I've done so far. And now we're going to do the vertical stretch by a factor of 2. So I'm going to multiply all those y values by 2. Still at 0, 0. And now instead of 1, I'm at 2. And here, instead of at 2, I will be at 4, which would be right around over there. So I will be am I doing? Like that. Okay, so now I'm at y is equal to negative 2 root x. Now my last thing I need to do is shift left 1 unit. Maybe I'll use red because I was writing in red. So which is the same thing as saying subtract 1 from the x value. So shift left 1 unit. So I've got this dot goes here. I've got this dot goes here. And I've got that dot which would go here. So now my final function, can I hit those dots? Looks something like that. And that would be my final answer, and that would be my y is equal to negative 2 times the square root of x plus 1. Okay, so that's what it should look like. Let's take a look at part B here. Now, a little bit tricky. What they haven't done yet is, you're looking in here, this doesn't look quite the way we want it to look. We want to factor out a 2 here. And you'll see what it looks like when I'm done. And we'll say y is equal to the square root of, so I factor out a 2 and I get x minus, now instead of a 4, because I'm factoring out that 2, it's dividing by 2, I get x minus 2. And then outside of the radical symbol, I get plus 1. All right, so thinking about what these different pieces mean, I've got a horizontal stretch by a factor of half. Where does that come from? Well, let me do my highlighting trick again. So this b value is 2, right? So since b is equal to 2, that's what causes the horizontal stretch by a factor of 2. All my x values are multiplied by 1 over b, or 1 over 2. So I'm going to multiply all my x values by 1/2. Okay, now some of you might be saying, well, it's not really a stretch, it's a compression. I would say don't worry too much about what word this is. Just think that by a factor of, this phrase here means multiply. So multiply, the horizontal values, that's the x values, get multiplied by 1/2. So in other words, yes, it's a compression. Okay, it's a sort of like a negative stretch in a way. It's a reversal of a stretch. So that's going to cause it to shrink, first of all, horizontally. The next is the horizontal shift right 2 units. And where does that come from? Well, here I've got this minus 2 piece, and that's where the horizontal shift of 2 units comes from. And the reason for that is that we have our h is equal to 2, right? So if this is negative 2, h is positive 2. If it's positive 2, you're moving to the right. And the last piece is the vertical shift. This is the one out here. Notice it's outside of the radical symbol, so it's a vertical shift of 1 up. All right, so let's start with our regular function. We'll start with a regular function here, 0, 0, 1, 1, 4, 2. We've got this one, goes like that. And then I'm going to say horizontal stretch by a factor of 1/2. So this piece, I'll switch to blue now. This one will go to 1/2 of its original. This one will go to 1/2 of its original. And now we have something that looks like this. And I just continue the shape a little bit, like that. So this one is now, after the horizontal stretch has been by a factor of 1/2. Now I want a horizontal shift of right 2 units. So each of these spots, I want to go right 2 units. I'll go red with this one. Actually, I should probably not go red. How about if I go another blue? If I go right 2 units, right 2 units, and right 2 units. So now I'll have something that looks like this. Now my last one is a vertical shift of 1 unit up. So 1 unit up means I need to go up 1 up to here. So this one is what I'll use red for. This one goes up 1. This one goes up 1. And here we have the graph. And that is our final one. So just to finish off, I would erase all the old ones. So when I erase all the old ones, Is it erasing? Come on. There we go. So there is my final piece. And that is y is equal to the square root of 2x minus 4, or you can write it this way with the x factored out, either way plus 1. Oh, one thing I forgot to do was talk about the domain, didn't I? Okay, so let's go back and let's take a look at the domain. So looking at this red one, the domain of this, just looking at it, what are all the possible x values? All the possible x values here are that x has to be greater than or equal to -1. Okay, so I'll write it out really nicely here. I'll say with the curly braces x, and then I'll say such that x has to be greater than or equal to -1, where x is a member of all real numbers. Now that we solved for the domain just by looking at the graph. If you just started with the equation, so if we started with, I'll do this on the side, y is equal to -2 times the square root of x plus 1. And if you were just given that function and you didn't want to graph it and you were asked, what is the domain there? So remember, what you can't do is do a square root of a negative value. So let's just take that x plus 1 and say that x plus 1 has to be greater than or equal to 0 because it can't be negative. And now if we just solve for x, so we subtract 1 from both sides. So x is greater than or equal to -1, which is exactly what we had here. So you can find the domain graphically. You can also find it algebraically by saying whatever is underneath that radical sign, whatever the radicand is, has to be greater than or equal to 0. Okay, so the second one, let's try that same method. So if we look at this, we can say, okay, the radicand is 2x minus 4, and that has to be greater than or equal to 0. So let's add 4 to both sides. So you follow most of the same rules with inequality signs as you do with equal signs, with equations. The big thing to watch out for is if you multiply or divide each side by a negative value, then you switch the inequality. So far we just added 4 to both sides. Now I'm going to divide both sides by 2. So I'll say x is greater than or equal to 2. And looking at our function, that is what we see, right? X is starting at 2 and goes greater than that. So to write out the function nicely, I'll do our really neat curly braces. I'll say x such that x is greater than equal to 2, where x is a member of all real numbers. And here's my curly braces there. Okay, it looks a little kindergarten-like with all the thick lines on there. We are now on example number 3. It's got this form, putting the plus 1 on the left-hand side and the right-hand side. The textbook likes to do that. I like to switch it right away, so I'm going to say y is equal to, now I'll put the square root of -x plus 2, but I'll be changing that in a minute, minus 1. So all I've done so far is I've subtracted 1 from both sides, but this is a lot like the previous example where I need to factor out. Now in the previous example I factored out a 2. On this one I'm going to factor out a -1. So square root of negative, and then I put my parentheses, negative, I put my parentheses, x minus 2. Okay, minus 1. So you see what that is. What happens is that my h value is going to be 2. It looked like it was going to be minus 2, but it's actually 2. So let's take a look at all the different steps. I think in this example, they don't tell us what the steps are going to be. We have to sort of figure them out. So the first thing that we're going to have, number 1, looking at this, is this negative value. That b is equal to -1. So what does that mean? That means that all of my x values are going to be multiplied by a factor of -1, which is going to cause a reflection over the y-axis. Over the y-axis. So my b is -1. There we go, and that causes a reflection over the y-axis. The second thing that I have here is that, looking at this minus 2, that my h is going to be equal to 2. And so I'll highlight that. Here, this part here, my h is equal to 2. And what that causes is I have a shift 2 to the right. And my last thing I have is this -1 business means that k is equal to -1. So I'm going to have a shift of 1 down. Okay, I'll just use my red here to show that. Okay, so, well, let's start off by having our regular function. Here is my regular initial function. And now we're going to have our reflection over the y-axis. So this is the y-axis. So now we're going to be moving this way. Okay, so that we've done this piece. Check. Now we need to, you know what, let's do this at the same time. We're going to shift 2 to the right, and we're going to shift 1 down. So 2 to the right and 1 down. So this one goes, I'll pick a different color. Here, I'll pick red. 2 to the right, 1 down. This one, 2 to the right, 1 down. And this spot, 2 to the right, 1 down. And now I've got my 2 to the right, 1 down. And now I've got my curve. So looking at just the red one now for the domain, looking at the graph, I could say x has to be less than or equal to +2. So if I put my fancy parentheses here, my curly braces, x such that x is going to be less than or equal to 2, where x is a member of all real values. Now let's try it like we did before by looking at the radicand. So I've got, well, I can take the negative x parentheses -2, or you can just go straight from the beginning in case I made any error along the way. I'll say that this minus x plus minus x plus 2 has to be greater than or equal to 0. So I'm going to subtract 2 from both sides. And now remember what I said before. If I multiply or divide each side by a negative value, then the inequality changes sign. So x is going to be not greater than but less than or equal to +2. And that is what I saw, right? This is exactly what I see. X has to be less than or equal to +2. So it's a bit of a confirmation. Okay, so moving along here, we've got another one, example number 4. Determine the equation in the following function written in the form y is equal to all that kind of stuff. So now we need to figure out what the equation is going to look like. Okay, so you'll recall our initial kind of points is a 0, 0 and a 1, 1. So those 2 points, the x changes by 1 and the y changes by 1. So looking at my 2 points here, I get something very similar. My x is changing by 1 and my y is changing by 1. Certainly my x is going in the opposite direction, so I'm going to recognize that there will be a reflection. But the first thing I'm going to note is that there are no stretches or compressions, which are, really talking about the same thing. There's no stretches or compressions. So in other words, that the absolute value of a is equal to 1, and the absolute value of b is equal to 1. So when those are different than 1, then you have some stretches. I do have a reflection for sure, so I know at least one of them is going to be negative. So what is the reflection? Well, normally, we have it going this direction, and it seems to me that what happened was there was a reflection that moved it this way, right? It reflected over the y-axis. So what does that mean? So number 2 is we have a reflection over the y-axis. So in other words, although the absolute value of b is equal to 1, that means that the b is equal to -1. That's what's causing that reflection. Here, I'll clean up a little bit of my mess here. So far what I've done is I've said, okay, this would go 4 and 2. It would kind of go like this, right? But it looks like things have moved a bit. There's been a shift. So which way has it shifted? It has gone 2 right, 2 right, and 1 down. So I'm doing those translations all at once. So the 2 right means that h is going to be equal to 2 and k is going to be equal to -1. So a is going to be +1, so over here a is going to be +1, b is going to be equal to a -1, h is going to be equal to a 2, and the k is going to be equal to -1. So when I write it all out, I can write y is equal to, if a is a 1, I'll just leave it. And now my b is a -1, so I'll just write a negative, left parentheses, x minus 2, right parentheses, -1. Okay, and that's what it will look like. You know, I think I'll pause before I do these last examples just to give you guys a bit of a breather.